Yeah, as I said, my name is Dror Helper. I'm a consultant in the fields of test-driven development. Not only, I especially like to help people write better code. That's my aim in life. Courses, mentoring, talking sessions, just like this one. Found out about this world in 2008. I started working for a company called TypeMock. TypeMock is a mocking company, create a mocking tool. And there I found out about the amazing world of unit testing. And since then, my interest in this field just grew and grew until I became a consultant in that field. Just to make sure, Java developers in the room? Any Java developers? Whoa. .NET? Okay, my crowd. Yeah, I'm a .NET developer some of the time. Like to write code in Java as well. Usually it's the other way around. More Java developers, by the way. And well, I guess we'll start because no way around it. I have a blog where I write about anything I find interesting, mostly software-related stuff, mostly TDD, unit testing, how to write better software. Okay, so the reason I created this talk was a few months ago I've been to a conference, met another consultant. That consultant came to me, asked me, he said he knows what I do, and he asked me, do you teach ATDD? Well, I said, not specifically, but yeah, probably. And he said, well, okay, and went away. And it got me thinking. So I went back to him and said, when you said ATDD, which is acceptance test-driven development, what exactly did you mean? And he said, well, are you using fitness? Do you teach people how to use fitness, a tool for ATDD? And I said, well, no. He said, okay, how do you gather requirements from business analysts to give to the developers? I said, what do you mean requirements? I'm teaching how to write tests for the code. I'm not talking about requirements. And he said, well, okay, so that's what I meant. And it got me thinking because when I say ATDD, I mean something completely different from that guy. And well, I started digging. I opened my browser, Googled a bunch of stuff, tried to find out what the hell is ATDD. And the only thing I could find is that every single place I saw meant something completely different. And I found a bunch of articles about ADD versus TDD versus BDD. And each and every one of them said something completely different as well. And so I started doing some archaeology in the internet, started reading books, tried to find where these methodologies, ideas came from, what the person who invented them intended it to actually be. And the result of that research is this session. So this session basically is an hour-and-a-half history lesson. Don't worry, I'm not an historian, nor am I anything resembling that, but essentially trying to find out the roots of all those methodologies became a mini history lesson. We're obviously going to talk about methodologies. The three big ones, ATDD, TDD, BDD, which is probably the reason you came to this room today. We are going to talk about books, lots and lots of books. Books are great things. I like to read books. I think it's a great way to acquire knowledge. Some of the books I'm going to show you, I read more than once, and each and every time I understand that the author tried to tell me something that I only understood a few years later. And it happens to other people as well. You can look up Ian Cooper's presentation on YouTube about what Kent Beck actually meant when he said TDD. Apparently not what other people understood. And we're going to talk about tools, and tools, because we are down-to-earth people. Some of us write code. We want to use this knowledge in another way in order to write better code, right? So in the beginning, as I like to say, there was chaos. And unfortunately, some companies still operate in the same principle of write software as fast as you can, hit the keyboard until something happens, right? Everybody had this boss at least once. And well, software development actually started that way. Well, As I said, some of us still there, but we are trying to evolve. And the first place I found that actually talk about proper methodologies, ways to write better software other than learn to type faster, was a bunch of practices known as the extreme programming practices. It all started in a project in Chrysler called the C3 project. The C3 project was an HR project. They wanted to take a bunch of COBOL code, which semi-worked for them, and calculated salaries, if I'm not mistaken, and converted to a new and shiny language of Smalltalk. That's way back, 1996. That's like ancient history computer-wise. We're talking like Stone Age. So they decided to write this code, and they had a problem. They couldn't meet the deadlines. And after a while, youngish consultant was brought in order to help with the performance problems. That guy was called Kent Beck, which you might know. If not, by the end of this session, you'll know Kent Beck. And that guy came and he saw that problem wasn't actually performance, it was the way that stuff was done. And along with the other guys in this project, that was an amazing project to be at. 10 very talented developers, some of the leading names in the industry, such as Martin Fowler, Kent Beck, Ron Jeffries, Don Wells, all working together to create better software. They managed to meet the deadline. After a while, the project was canceled. There's a lot of, you can find a lot of stuff written about it from those 4 guys and other guys, what worked, what didn't work. But all of them went along for new projects, and extreme programming was born. The idea behind extreme programming was we'll take a bunch of practices to enable us to write better code. And we'll do it in a sort of iterative feedback-based way. We'll start from a plan and go to iteration plan. And from there, we'll write acceptance tests to see that the requirements are actually possible and doesn't collide one with another. And then we'll go to and have stand-up meeting each morning, and you might know this practice from other methods, such as Scrum, because all those guys talk together all the time. And pair negotiation, we'll talk about what's going to write, then write it, actually doing pair programming, and we'll do it using unit testing. First time around with unit testing mentioned. Actually, not the first, but one of the first times. And pair programming, we'll have code and all over again. And each and every time we'll get feedback, see if we're doing the right thing. If not, we'll change it a bit. Although there are, I think, several practices, none from which are pair programming, TDD, test-driven development, that came out of extreme programming, which was released in 1999. I don't know about you. In 1999, I was before college. That's way back. And I see some young faces here, probably being in school, right?
No, I'm the same age.
Oh, yeah. Same as that? Oh, that's great. You look younger. Software industry being a very young kind of industry. So they talked about developers writing tests, which is a groundbreaking idea even today, that developers should write a test. The very idea that developers should test what the hell the thing they're writing instead of just throwing it over the fence for the poor testers to try to understand how to get it to work is a great idea. And it comes from the basic notion of if small testing is good, more tests better. And that's actually the way it's written in extreme programming. And we're talking about 2 types of tests. Unit test, which is for the developers to understand that the feature, the actual code I just written, actually works the same way, works exactly as I intended. And acceptance tests are supposed to test the actual specification. Not much details on those 2 in 1999, but the idea was there. And from there came the whole idea of unit testing. Now, unit testing, brief history as I found it on the internet, started back with Intelligent Framework. I found an article about why they did Intelligent. I hope I'm saying the company's name right. They explained that developers need to write the code, test the code they're writing, not just throw it over. And they're talking about the way to do it. Couldn't find an actual unit testing framework for that. The first unit testing that is talked about is xUnit. xUnit Smalltalk unit testing. created by Kent Beck, C3 project, and every other project he worked ever since. Well, obviously now I believe he consults in Java or newer languages, but at that time it was small talk. Another thing to know is that, as I call software archaeologists, claim that there was never an xUnit framework. Never existed. xUnit was actually Kent Beck going to a team and says, you need to unit test, and for that you're going to, the first thing on order of business we're going to do, not again. First order of business, we're going to write the actual framework to write the unit test. So xUnit was basically Kent Beck coming to these guys and says, now we're going to write a unit testing framework. After a few weeks, we'll actually get to write unit test. Obviously, xUnit frameworks were developed using TDD, which is a bit of a recursive method to do that, but great idea in order to teach how to write unit tests. On the plane to UPSLA being an object-oriented programming conference, Kent Beck and Eric Gamme looked at all those xUnit frameworks and converted them to Java. And JUnit was created. JUnit essentially, well, I'm not 100% sure, but seems to be the first unit testing framework that was created to give to other people to write unit tests, not on the same project. They did it on the plane ride because they were bored. JUnit essentially had a base class, the test case base class, and you would inherit it in your class. And your class became magically a unit test in fixture with unit test inside. And that idea went over to C++ with CPP unit. Michael Feathers, who know who Michael Feathers is? Okay, there's a great book called Working Effectively with Legacy Code. Read it. If you want to unit test, you'll probably have a lot of legacy code on your hands. And Michael Feathers started his book by defining what legacy code is. And by Michael Feathers' definition, legacy code is code without unit tests. So obviously you needed a unit testing framework. For that, CPP unit for C++. And good example, very old book, still relevant to this day. I use it all the time with my customers. With the clients, you come, you have a big code base, a lot of mess, and you need to actually get it in order, and you can't do it all at once. The ideas in that book will help you. Fast forward a few hundred unit testing frameworks, and we got to 2002 when NUnit, the .NET unit testing framework, got to version 2. Why version 2? Couldn't find version 1.0, not even on the site, just 2. So I could, it was created in 2002. And it was a very nice idea. They said, OK, we have a problem in .NET. We can inherit only one class, right? Only one class can be derived in .NET. Many interfaces, one base class. So we don't want to waste that class on their base class for unit testing. Let's use attributes instead. We'll put an attribute saying this is a unit test, and that's metadata. We can use reflection to actually find our test in the code to run them. And it was such a successful idea that the Java people saw it and took the same idea to Java. And you can't find the base class in JUnit anymore because they're using attributes instead. All came from NUnit. So it's a closed system, and everybody learned from everyone. And today, if you go to Wikipedia at unit testing framework, you'll find a few hundreds of those for every conceivable language you ever heard of or never wanted to learn about. So what is a unit testing framework? A unit testing framework essentially combined from a bunch of fixtures, which in the .NET Java object-oriented world usually map to a class that holds inside a bunch of tests. Here we can see in Java. And the idea is very similar. Take this idea to C++, .NET, whatever. It will look roughly the same because every unit testing framework must do 4 things. Have the ability to set up the environment before the test, run the test, assert the result, and tear down, clean afterwards. And all of them have those capabilities. In this case, we have the before and after, that will run before and after the test. In NUnit, they are called setup and tear down. Same thing, though. Take this code, change the annotations up, the one with the ampersand in the beginning, to .NET attribute, the same thing will compile. And we have a bunch of tests that execute our code and assert it. And those are the bunch of xUnit test frameworks. And you can find many. Only in the .NET space, I know about 4 mainstream. Not all, I'll try to write something in my garage thing. 4 mainstream unit testing framework, Java I know 2, C++ at least 3. There are a bunch of those, and you can find a full list. Now, a unit test actually has nothing to do with the unit test framework. It's an actual code. It's a method. The unit testing framework just enables me to run that code. That's it. And it's a code, it's a test that has very specific functionality. Very easy to say, very hard to do. We developers, we don't talk specific, we talk generic. We want a code that does everything, all possible case. Unit tests say exact opposite. We want to test something very specific. And clear pass and fail because we want to automate it, run it automatically, either on my machine or the build server. And finally, runs in isolation. 2 unit tests can't affect one another. I should be able to take the unit test from my machine, choose any one of you who bought your laptop, put it on your machine with my code, obviously, and run the test. Nothing that uses databases, web services, something specifically I needed to install, or whatever. No third party that I can't have in my code. Obviously, this is the perfect world. Sometimes we make a few, we can be a bit lenient, but this is the idea of unit test. And it's a great thing, that unit test. It gives me quick feedback. The minute I write a unit test, I know if the API, the way I wrote the methods, makes sense. If I have a unit test which is 5 screen long, I might have a problem. It takes a lot of initialization in order to just execute this small piece of code. If I have a method that gets 14 different parameters, I might have a problem. And I'll find it because unit testing is just like a mirror. It forces me to face my code and understand what the hell I just did. Helped me to avoid stupid bugs. I don't know about you, but when I was younger, my second job, I used to write the code as fast as I can, commit, tell the tester, OK, test it now. He would press a button, everything will crash. No, null reference, out of bound exception, whatever. Stack overflows. You can't have those with unit test. If you run your code, you won't have those stupid bugs, the dead on arrival code. Obviously, immune to regression, which is what people always think about when they write unit test. If I write in a unit test, I can have a bug that will cause the test to fail. I'll find out as quickly as possible when the bug will enter my system. If I have a few unit tests, I can probably confidently change that code without breaking anything. Or if I would break something, I'll know about it as soon as I break it, as soon as I run my test. It would bring us that I can change my code without fear, because all of us has this method. The method that we're afraid to change, right? The code that Dave wrote and then left the job, and no one's want to change it because the last guy that tried to change that code was left at work during the weekend trying to fix whatever he did. Unit test, no problem. And everybody likes to talk about documentation, because once I have tests, it's very easy for me, future me, to see what past me did and understand that class can be executed with those parameters. This is valid input, this is not valid input. And I write code and I read code, and I can understand from the unit testing what the hell they're doing. All that good and nice, but we are here to talk about test-driven development. And it all started with this book, Test-Driven Development by Example. Not a big book, but what Kent Beck says in one sentence, people have been investigating for years afterwards. It's not a big book. Have 3 examples, the second one being write your own unit testing framework. Now you know why. And it talks about the test-first approach. And it takes 3 different problems and guide you step by step as you solve the problem without planning to. You write a test, and then you write a code, and this is essentially the cycle that is TDD. Would also refer to as red-green refactor. Anyone know about that guy? Red-green refactor? Yeah. Red-green refactor is the, I don't know, the buzzword way of saying that. Red, I write a failing test. I have to emphasize that's a test, not tests, singular, because I only do a single step in each cycle of TDD. Then I'll write the minimal amount of code in order to make the test pass. Again, very hard thing for developers to do. I'll put a few things along the line just because I remembered something. And finally, I'll refactor the mess I just created. And this cycle goes test by test until I have a full feature written. TDD has two problems, though. The T and the last D. That's the two problems. TDD, the middle one, I have no problem with. Ken Beck did a big mistake calling it test-driven development. It starts with test. Developers don't like to test. And it's very hard to explain to them that this is not actually testers testing. That's me finding that what I wrote actually works. In one company, what we had a big form. You know Windows forms? Anyone still using those? Yeah, that's OK. Many companies still. WPF is not the only way. Yeah. So Windows form, we had a big Windows form called Form 1, the default name. It has buttons with very good names, button 1 to 50. And whenever a developer would finish a feature, it will drag a new button in, get button 51, double-click, get the handler for it, write the code. It just a simple test-like thing in that button. Press the button, see that nothing crashes. That's OK. Unit tests essentially are the same, with the benefit of actually getting it to run automatically and not rotting along the way. Because when I finish button 51, I have no knowledge of the other 50 buttons. In fact, I can guarantee, without running this actual code, which is lost to oblivion because it was a few years ago, that buttons 1 to 11 probably didn't work by the time I got to 51. So unit test is much better. But again, the word tester, it's a bit of an obstacle. The second D is also a problem, because people tend to skip over the second D and go from test development. OK, unit tests are great. This is another way to write unit tests. It's before my actual code, which is plain old weird. So I'm not going to do that. I'll write the unit test afterwards, missing completely the point. The point is not the test. The tests are a byproduct of the process. The process is design. I like to call it test-driven design because that's what I'm actually doing, designing my code, one step at a time. Let's see an example. Roman numero kata. Sorry about my slides. The idea is to write an Arabic to Roman converter. You might know that kata. If not, just Google for it. You'll find a few solutions as well. The idea is I give it an actual number, say 15, and give me the Roman numeral representation. That's how I start every single TDD session I have. I'll write the actual class with you. What will happen now? Compilation problem, right? No one written this code yet. So the next step is to actually implement the class. Now I have the class and everything compiles, and the test actually passed, but doesn't do anything important. So let's write the actual test, and you have to forgive me, I'm not writing the beginning, the initialization part, this thing, because it's too long, and I don't want you to break your neck. So if we are the first test, I'll give it 1, I expect to get I back, right? That's the Roman representation of it. So first line new, then convert 1, and assert .equal.java for you, I result. Always in all the unit testing framework, first you say what you expect to get, then you get the actual result. I think that should have been the other way around, but that's how JUnit started it, so everybody copied. So what will be the simplest thing to write here? Any suggestions? Return I, right. So first of all, this is for compilation, because first thing in order, I want to see the test failing. In this very trivial example, in the first step, looks a bit stupid. I grant you that. But it happened to me that I'll write a unit test, run it, and it will actually pass. So I always run it and see that it fails. It's a good practice to have. Why would the test will pass? Either I already implemented it without knowing. It happens. One requirement collides with another requirement. It's not a bad thing. Or I wrote a bad test. Bad test will pass, even when I expect it to fail. And the best way to know that the test is actually a good test is to make it fail. So this test failed, and as you suggested, return I and run again will make the test pass. Obviously, if I go to my boss and give him that kind of a solution, I'll get fired. So we're not over. We're not done yet. So the second test, let's try 2. I'll write that one, no compilation errors, so I'll run it, and the test will fail. Again, what is the simple thing to do? Any suggestions?
If no equals 1, return R.
Yeah, exactly. Yeah. The other around though, but everybody is entitled for his own way, but the same, essentially, if I equals 2, return 2, otherwise return I. And it will pass. And that's good for us. Now I notice something. I can refactor this code to make it better. Because I have 2 examples for 1 and 2. And, judging from those 2 examples, only those 2, I can use a loop to get the exact same result, right? So I refactor it, run the test again, everything is fine. This is not the end of it, but the end of my example, because I want to show you more stuff and go ahead to BDD and ATDD, but you can look it up. And the amazing things, the reason I really like this, I got this question in a job interview, my very first job interview. That's why I like it. And I didn't know that. It took me 2 hours to actually write the stuff, to find a way to convert it. I did design and tried to find the algorithm with examples, and it was hard in the middle of an interview. If you look it up in the internet, you use YouTube or something, write Roman numeral in whatever language you want, you'll probably find an example in that language. You'll see people doing it in 8 and 15 minutes. Obviously, they know where they're heading, but TDD actually helped me find the design faster than actually trying to design it. Look in my blog. I have an example there of TDD, which I like to give as part of a unit testing course. And the reason I like to give it because I was bond over there. I worked for TypeMock, as I said. We were doing unit testing tools at the time. And I was thinking I'm doing TDD. I didn't do TDD at the time. I know it today. And we did pair programming, though. And we said we had a very difficult problem, me and the other guy. We couldn't find a design that to solve a very simple problem of returning 2 values, different values of some type, any type in .NET. Struct, class, int, string, whatever. And after 2 hours, we got yelled on by our manager at the time, the team lead. He said, why aren't you doing TDD? We said, obviously we're doing TDD, but we want to do the design first, which is not TDD. And he forced us to do TDD, and after 2 hours, it took us about 50 minutes to get the design right. So that's, if you look it up, you'll find it. Anyway, what I showed you just yet is today is known as classic TDD, because there is another brand of TDD, which we'll get to shortly. And the classic TDD talk about triangulation. I'll take a bunch of things, a bunch of inputs, and I'll get to the design by shooting at it until I find the proper point. By refactoring all the time, I'll find the design on the way. It's also called bottom-up, because I start from inside the method, implementing 1 step at a time. Works very good with algorithms when I have some sort of internal machine, internal states. And also, I need to verify all the time that I got the right result. You say, I need to do this assert. So I need somehow, it's always state-based. Either I get the result back or I check some property to see that I'm in the right place. Unfortunately, that's not enough. Some programs don't do that. And usually, teaching TDD, that's what we teach. And then people go to work, find out that the code are much difficult than a simple thing that get 2 inputs and put 1 output back. The examples seem very simplistic. I don't expect you to buy into TDD by seeing the Roman numeral example. It's too simple. Your code, hopefully, do much more difficult things. The real world, we have a thing called dependencies. We do have database. We do have web services. Otherwise, software does absolutely nothing. And we do need to do something with it. For example, this thing. This is an actual code, actual process of a client of mine. They have like this voice over IP program. Think Skype. So someone else wants to call, so his client is calling the server. The server sends a message to some communication element. It gets to a class called communication client of some sort, which raises an event. The event got to me, the phone client, my code. I need to notify the UI that something happened. The UI, the user can press either accept the call or reject the call, doesn't matter. And it goes all the way back and connect to the server if I accepted the call. Now TDD this. And I actually have another session in which I show how to write this using TDD, but not using the classic TDD though. Because we need other tools. We need isolation, also known as mocking. There are two people in the world that call it isolation. I'm the second one, and the reason is I learned it from the first guy. But basically, I think it's a better word. The idea is to replace the production code with my own code, because everything is classes. I can take a class and replace it with another class that does absolutely nothing or whatever I tell it to. And it enabled me to do two things. Take the server, database, whatever, take it out of the equation, because I still want to write unit tests and do TDD. And I can test interaction as well. I can say, client or server, did anyone send you that message? Without going to the server, just to my fake class. Essentially, if you look at the participant in the scenarios showed before, we have the server, communication, client, and UI. What we want is to test the client. We want to use that to write TDD, and this is what I actually did. People don't believe me. They say, well, it won't work in the real-world example. I created that client from scratch using TDD. Not always working, but most of the time does. So we want to take the UI out of the equation. I have no way to do that with a unit test, as well as the server. So what do? I take the UI out and put a test instead. Instead of the UI executing my code, the test will do that. That's OK. And I take the server part out and put my own fake class. And I do that using isolation and mocking framework. Most of you are .NET guys. I have a session tomorrow exactly about that. Unfortunately, not enough time to talk about it today. But come tomorrow, we'll talk about that. And then we get to something new. I didn't know it had a name until I started digging about all this TDD and BDD stuff. It's called London School of TDD, which is fortunate because we are in London. The idea is to do TDD in a different way. Instead of triangulating, I'll do it from the outside in. I'll try to run the whole scenario without the dependencies. OK? I'll test the interaction instead of testing results and states. And everything is behavior verification. Also known as the mockist TDD, and the book for that calls Growing Object-Oriented Software Guided by Tests. Very good book. Some people said then the student TDD once they read that book. So let's see a very quick example of the London-style TDD. Here we go, phone call. This is actually the same phone client we talked about. So this is a test using fake objects. In this case, fake it easy. That's one of the .NET mocking frameworks or isolation frameworks. And essentially, you don't have to know much about it. All you have to know is here I create a fake of phone client. OK? The type is actually a fake of phone client. I can debug it and show you in a minute. And then I'll create a new phone and pass it to the fake client using dependency injection. And here I'll tell it, that's a very weird syntax. That's .NET for you. Events are not first-class citizens, so that's the way the fake mocking framework uses to actually raise events, because it's not a real object. I need to tell him an event appeared. So I say, well, just say on phone ring now. And then I'll call accept call. And here, this is the big benefit of using fake objects. Connect must have happened. This is a test essentially that says when the phone rings and someone accepts the call, then connect to the server happens. OK? Readable? And I did it without any external dependencies, no server, no nothing. And yeah, we can. And I actually well, not here, but you can go to Git under Dror Helper. You'll find this example. What I want to show you is that fake client is actually really a fake client. Okay? You can see that at the back. So this is one way of doing TDD, and if we'll run along, stop it. If we'll run along a few iterations, here you go. This is all the tests I've written as part of TDD, and I actually created a state-based phone client to answer a call and reject it if needed. Here we have accept without a phone ring and all the scenarios using TDD, the London way of doing TDD. By the way, you don't have to know it's the London way of doing TDD, because most places you'll see TDD is actually doing that without explaining it, because most people understood that this is a good idea, but they didn't know that there's a name for it. So which one should I use? Well, the answer is both. Usually what I'll do, I'll use the London style to begin with to get the scenario in place, and then each and every single component, I'll use the classic TDD in order to create it inside. I used to do it for years without understanding that I'm actually doing two different things. But now when you see London or classic or Mockie's type of TDD, you know what they're talking about. So TDD, we got sorted out. Let's talk about ATDD, which seems like the next step. It was created a bit after TDD, but not that later. In his book, TDD by Example, and that's what I said, in one sentence, Kent Beck hammers things that it took them years to understand. He says, when you're doing test-driven development, you might have a problem. The problem being that I want to get to this door over there, but on my way to that door, I did a bunch of small steps and ended up over there. And actually, always was big on unit testing in TDD, and then one guy came to me and said, well, all nice and good, and I'm doing TDD, like you asked me to. But how can I guarantee that I won't get to the wrong place when I finish? How can I guarantee that I actually implemented the feature correctly using TDD? And that's a very good question. At the time, I was very zealous on TDD and said, no, you don't need it. Obviously, TDD is good enough. Well, now I know I was wrong, but and Ken Beck says the same thing back in 2002. In 2002, I didn't finish my university yet, and you already knew that. But he continues to say in the same page that doing application-wise acceptance test-driven development is not good. It's a bad thing. That's what he says in that book. It means I need to get the users, either client, business analyst, project manager, whatever, to join me in my cycle of writing requirements as code, which will never work. I have problems getting them to write the actual backlog. How can I get them to write tests? It will make the process be longer, much longer. The minute I'll start putting the users in, the whole feature, you call the manager, well, I need you to change the feature, I need more features. He's in the middle of a meeting, he has more things to do, and it will take more time. And we're talking features now, not units. So to get a feature in place might take me a few days, a few weeks even. And I'll get a slower response time. The feedback will get to me late. For those reasons, he says in page 199, won't work. Let's see if he was right. In 1996, we talked about extreme programming. That's when they began to talk about acceptance test-driven development. They talked about acceptance tests, not acceptance test-driven development. In 2002, as I said, Ken Beck says, not a good idea to do ATDD. And the same year, Walt Cunningham went and created FIT. FIT was a tool in which the business guy wrote a bunch of things in Word or Excel, and the developer wrote a bunch of code, and they actually connected to one another. That way, the business guy got to write the requirements that actually ran. And then Bob Martin took Word's FIT and another invention of Walt Cunningham called the wiki, and combined them together Not sure if with or without Ward Cunningham, and created fitness. And fitness was hugely popular. Many, many companies till this day use fitness. So I guess Kent was wrong, well, to some extent, not completely, and we'll talk about that. The idea of acceptance test is to determine if the requirements were right. I don't know about you, but it happens to me more than once. I got a requirement that actually collided with another requirement. It was complete opposite of another requirement. We wanted to always be on. That's good enough. Well, after 2 hours, it should turn off if the client has asked it. So what about always on? Well, I'll think about it. Ever got this sort of requirement? Get it? Well, I have to say, daily. So now you get to verify that the specification actually works using user stories and using a requirement. And we can do that as early as the requirement stage, and then in the implementation stage, see that we actually got that requirement right. Acceptance tests and unit tests are very similar, though. Both are automatic tests that verify state of code. Both can be written using unit testing framework. Because unit testing framework essentially is just a bunch of code. I can write whatever I want there. When a client of mine had a database with a lot of logic inside the database, well, not sure if that's the best practice, but that's what we had. We wrote tests that actually turned the database on, threw a bunch of data at it, changed a few things, and tested the result. That's acceptance tests. We tested end-to-end. And I did it using NUnit. Okay? It is possible to use unit testing framework. Not necessarily, but possible. In fact, another great place to look for ATDD in the trenches. Very good example using JUnit to create end-to-end application. They do differ. Acceptance tests and unit tests. Unit tests are very fast. How fast? Less than a second fast. Acceptance test, well, depending on what you're doing. Could take a few seconds, maybe even a few minutes. In fact, I know one company I've been to in a session, the guy from that company, they're using BDD, but they're using acceptance tests. And the test suite ran for 2 hours. That might be a problem. That's what we get with acceptance tests. Unit tests have no side effect. Acceptance tests do have side effects. In that scenario in which I change the database, if another guy would run the same test with that database, one of us will fail because we changed in the same state. We have a shared state between us. That's a problem. Both of them, unit tests are very simple to run. As I said, copy to other machine, run everywhere. The acceptance tests, dependent on the environment, you might need to raise an environment. That's where those setup methods come into place. Unit tests verify that code works. Acceptance tests verify that requirements are right, and so on and so on. They are different, but they can look the same if you don't know what to look for. In fact, many times when people complain about the performance of the unit test, when I go into the unit test, I find out they're actually running acceptance tests. They are actually calling a server or running the database or doing something along those lines. Not a bad thing to itself, but it's good to know. I usually split them, put them in different assemblies, so I'll be able to run them differently. When I run the server with the whole environment, I run the acceptance tests on my machine, unit tests. As I said, the two tools that started this movement was on your left. Fit, write the code, write the requirements actually in Excel, or fitness in a wiki. And the idea is that I create a sort of a table with the inputs and outputs. And I use fitness in order to connect that table to actual code. And it will run actual code, and I can see in the wiki, red for failing tests and green for passing tests. That's the fitness or in fit way. It's very nice because users can read it. It's English. It's what we call user-readable and user-writable. In the case of the wiki, they can change the requirements by themselves. They don't need me to change it. And some users like that fact. It increases their confidence that I'm actually doing what they asked me to. And I get to verify that the requirement works. And on the way, same as unit testing, I'll get a safety net that makes sure that I'm not breaking something I already created in the past. Also, a friend of mine, a consultant, what he usually do with those things is get a QA on board. You tell the testers, you're in charge of requirements. That's your domain. The very analytic testers know how to take a requirement and write it in a way that us developers can write code. Why not take another step? Make them write it in the tool, and the developer will implement it. And you get all those arguments. You know, you have a bug. Now, that was intended to be this way. Thrown out the window.
Some like spec flow?
No, that's BDD. We'll get to that. Yeah. Yeah, but same idea, though. Exactly same idea. That's why, well, we'll talk about that. So the ATDD cycle. We talked about the TDD cycle. Let's talk ATDD cycle. We start with red, but this time it's a failing requirement. That's a big theme. Could take days to implement. So in the meantime, what I'll do is use TDD to actually make that requirement pass. I'll do a bunch of unit tests along with those acceptance tests until it turns into green. I might need to refactor, but usually no, because I did it as part of my TDD cycle. This is a very good example from 2011 of the actual benefit of ATDD. It's not the test, it's a conversation. We discussed the user story in order to create that table. That table comes out of us talking about what we need to implement. And then the developer will develop it, get to a demo, and we get to do it all over again. Now, back then, in 2002, 2003, there was no clear process. This is still not a clear process. But we did find the process along the way, also referred to from time to time as specification by example. Sorry about that. Now, specification by example is a nice idea. And the first one to talk about the idea was Martin Fowler. Martin Fowler, again, he worked in the C3 project. He wrote the refactoring book, if you know about it, big, heavy book about refactoring, and a bunch of stuff about unit testing as well. And he says specification by example is a contradictory term because specifications are very broad and examples are very narrow. And in order to write all the examples for one single specification, I need more time than I can possibly have. And he actually talks in the context of TDD. He talks about the unit tests being actual examples for the specification and the inability to write enough unit tests to get the whole specification in place. And he's right, well, obviously, when you think about it logically. Even the simplest example, let's say a calculator, how many examples can you think in a single calculator, that simple, Microsoft calculator? I need to test any number possible, right? From minus to plus with 0, impossible to do that. But obviously, if I'll take the negative number, 0, and the positive number, one of each, I'll get enough example for that specification for, I don't know, adding two numbers. So he talks about it. He says that's a very broad idea. Someone else took the ATDD and specification by example and made a process out of it. His name is Gojo Edgic. And he started with this book, Bridging the Communication Gap. He went the other way. He said, well, testers and developers don't talk too much. When they talk, they probably shout at each other, right? Yeah. This is a bug, not my bug, your bug, cannot reproduce, et cetera, et cetera. And he talks about how to use acceptance tests. We're not talking TDD, ATDD, acceptance tests in order to bridge a gap, make them talk in the same words to one another. And he has a nice process in place. There's another book, Specification by Example as well, which he wrote. And he talks about how we create those examples, how we go from the business goal down to the living documentation that is the test. Now, ATDD has one clear requirement. Get the stakeholders in place. They need to be part of the process. Otherwise, you'll probably end up with what Ken Beck said. Doesn't work, they won't help me, it takes too long. And you have to remember that while I'm showing tools here, they are just examples of tools. You might find a business person who is more than willing to write code, or someone who is more than willing to write Excel charts. You need to make sure the tools are good enough for them to use, because we can write code to that in many, many ways. So you need them in place for ATDD to work. Not completely true. You need them in place in order for this process I talked about to work. As I said, I've been doing ATDD forever. I just write unit tests in a broader scope and call it ATDD. And it is ATDD. But I don't get the buy-in out of the business people that way. And I miss something along the way, but at least I get to know that I actually implement the feature as I understood it. Which brings us to the next guy called BDD, Behavior-Driven Development. Anyone knows about Cucumber? Well, in a minute, we'll talk about Cucumber as well. That means that you weren't in Seb workshop yesterday. There are many ways to mess up with TDD. In fact, when teaching unit testing, I dedicate at least half a day of talking about those ways. Because getting TDD wrong is very easy. It's very simple. Because it's a method. And you can write, well, good developers can write any code in a method, right? You can write bad code. I can write tests that no one can read. I can write tests that actually mimic whatever my code is doing. Instead of testing it, I'm just doing exactly the same. It's not testing. That's just copying the code in a test, and something will happen. The code will change. That's an absolute guarantee that the code will change. You'll find bug, you have new features, the code will change, your test will remain the same. Now you have two possible outcomes. The good outcome, the test will fail. The bad outcome, the test will not fail. And you keep on testing the wrong stuff forever. Test without focus, web developers, which are people who know how to write software that tackle a bunch of requirements, very broad ideas, face unit testing for the first time, they have a problem. They need to write very specific things, like we saw in the example. That's hard. That's very hard. And when you do that, you actually end up with things that look something like this. Let's see if I have it open. No, obviously not. Presentation. Here we go. I can show you that because the company no longer exists. So this is, I got there. I used to work for that company, not as a consultant. And I got there and I saw this test. Okay, that's not the bad part. This is actually just an XML file. That's okay. And another XML file. And we'll get to the test in a minute. You know what? Let's see. This guy is actually better. Here we go. And I know that I'm going to a world of pain the minute I see that's using the Microsoft unit testing framework. The minute I see someone writing this on a test, I know nothing good will happen. Developers write comments where they feel bad about their code. No way around it, sorry. There are good comments, there are bad comments. I tend to see the second kind of comments all the time. And not only did he write a comment, he also written a description for the test. That means he really felt bad about this. And when we go in, we'll see what he felt bad about. Here you go, that's the second test. We see regions essentially same as comments, and the tests go on and 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 on until here. What happened? Well, he was in, he tried to test something simple, got to some state with this code, and said, okay, now I can test other things in the same test. Because that's the way we write code. That's the right way to write code, not test code. And so if I'm here, if I'm already here, why not test another thing on the way? And I told him, do you have a problem there? And he said, yeah, right, but I'm testing a scenario. You see, by the name, you can tell there's something wrong here. Name says absolutely nothing. We'll get that in a minute. He says, yeah, I'm testing a scenario. I said, well, that's a unit test. That's not a scenario test, first of all. Second of all, can you tell me what happens here? And he tried to fool me into thinking that he actually understands what he wrote here. But then I said, well, okay, didn't want to argue too much. It was like my second week at that job. Didn't want to steer too much waves. And after 2 months, that test failed. And I was very happy deep inside, but I tried not to gloat. And I said, well, that's okay. When tests fail, we actually caught a bug. That's a good thing. And I said, well, okay, can you spot the bug? Why the test failed? And he says, oh, no idea. Can you fix the test so it will pass? Well, obviously no. To this day, I have no idea how to do that. And we just ended up deleting the test. Now, that's a very common thing to happen in unit tests when you start with unit test. Because people think they're writing code, and you're not. You're writing something different. There's a big confusion about what is an actual unit of work. What is the unit in unit test? You'll find philosophical argument about it. People claiming it to be a class, and those people are this guy. I tested all the properties, 100% coverage. No, that's not the idea. We are supposed to test units of work. This is a system I worked on. The idea was that we had a bunch of sensors connected to some logical controller, programmable logical controller, would send us raw bytes, raw data. That will get to this client. The client will get the raw data, all byte arrays, endless byte arrays, convert them into classes. Do some logic to keep alive the connection between those two, but other than that, just convert it into classes. And then the business logic will get the classes and actually do something with that and change and exercise commands on our domain model. Now, this was my task at the time. And in the beginning, I thought unit of work equal class. So I've tested each and every one of them in isolation. Very simple when you have a mocking framework. I created a mock for that guy, and for this guy I put the test, and the same here I created a mock for that guy, for this guy I put the test, all is well. And then I noticed something. I noticed that every single week I would spend a few minutes fixing those tests without any bugs to show for it. The test will fail. Why did it fail? Because I've changed the data. I've changed the classes passed between them, changed the protocol all the time. It was still in development. And every time I did it, again, two possible outcomes. First outcome, nothing happens, has continued to pass. That is actually the bad thing to do. Second, the test fails. And then try to fix the test and add the code, because I didn't find any bug along the way. And then I changed it. Instead of testing those two in isolation, I've tested them as one single object. Because the unit of work in this case was this part. This part, get information from sensors and do command on my domain model. And this is what I care for. And it took me a while to get there. And then a new employee got to that company, and he knew about unit testing. He was a very bright guy and came with TDD experience. And he saw what I did. Always nice to have someone else to talk to about those stuff. And he said, well, you're doing a mistake here. This is not a unit. Those are two classes. Two classes are not a unit. And at the time, I didn't have any good explanation why I did it. Now I know that it is a unit. And I said, well, I don't care. Because that's simple. And I don't need to fix it every day. And that's what I'm going to do. And it's usually a matter of scope. You have to find the right scope. Too small, you get to fix a lot of tests along the way. Too broad, your test will fail all the time because you're doing too much. And that's hard to find. And every single project I've been at, finding the scope in the beginning is hard. You might have enough experience to think about your project now and know what is the actual unit of work. I usually try to put it in a sentence. This does that. If this does something, only something, one thing, then okay, unit test. But not always work. So, obviously, my revelation came a bit late because someone already understood that, and he understood something else. And we'll get to that someone. He understood that when teaching TDD and unit tests, people have the same questions all the time. And I get those questions all the time. How do we start? What do I test first? What is that unit of work? What don't I test? Well, people ask me that, I say, well, obviously, you don't test UI, you don't test things that don't have any logic in them. If you have a method just called another method, you testing a narrow scope, just increase the scope a bit. How much things do I put in my tests? What do I call that test? The number one hardest thing in development is naming stuff. I have a tough time naming the tests and naming my code. And why did the test fail? Which is unfortunate, because when a test fails, you have to know why it failed without debugging, without actually going into your software and trying to understand it in the perfect world. And that guy was Dan North. This is Dan. And then said that the deeper he got into TDD, he found out that it's not exactly a simple thing, a simple experience. You'll go, you bump into a wall, you say, okay, that's not the right place to go, turn right, bump into another wall. Until you find a bunch of best practices, good ideas that you need to do. And as I said, half a day of a course goes to best practice, at least half a day. Because there are so many pitfalls, so many ways to get it wrong. And that article, published in 2006, I found about it, well, much later, at least 2008, was called Introducing BDD. That's the first time someone talked about the BDD. He's the guy who invented it. And the article actually doesn't talk much about BDD. It talks about something completely different. Start with talking about method names. This is JUnit test framework, the old version, using inheritance, extending test case, okay? He says there's something interesting about, there's a big problem with those unit tests. The problem is the word test, as I said. The major problem with TDD starts with test. Developers don't like the word test. And when you write the word test there, you get things wrong. So let's get rid of it, the word test. Now I can actually understand what happens here. Customer lookup, that's what I'm testing. Find the customer by ID. And fails for duplicate customers. How easy is that, right? Just by removing the word test, which masks the intent. With those names, I cannot go wrong. The names are very important. The name focus me. I teach people, first thing I teach about unit test, after going through the formality of unit testing framework, is name your test correctly. Because once you give it a good name, you can't go wrong. You have to specify exactly what you're doing. You can't write a broad test. You can't write nonsense inside. In my example of bad tests, the number one thing I notice is that they don't have a good name. The name will be customer test, for example, or test 1, 2, 3. Well, obviously nobody will call it test 1, 2, 3, but someone will call customer test 2 because I had the customer test 1 and this is customer test 2. Those, well, I changed them a bit, but I saw those names. Or this one, this is purchase order test new, because there was purchase order test old. This is the new one. Purchase order does quite a lot of things. How can you write it in one single test? Now, Dan North talked about how to write a test. We'll get that in a minute. There's another guy called Roy Oshrov. Wrote a book called book about unit testing. Forgot the name in a minute, which is very unfortunate. I know the guy. He's the one who taught me unit testing. And he talked about explaining what you're doing in the test name, because that's the first thing you notice when a test fails. Calculate task invalid near log error to file fails. Why did it fail? You don't need to know. Well, obviously it didn't log an error to a file, yeah? By reading the name, the first thing I notice when I see the test, and when I see the test failure, I know what happened. More than that, by writing these names, I force you to actually write a good test. Unless you want to lie and write a good name and a bad test, you can do that, intentionally or unintentionally. But this thing helped me to focus people on unit tests. Dan's ideas was to think about the names with the word should in the beginning, in the middle. Orders should be created. That's what the test does. Orders with no product should fail. Once you put should in, you're explaining what you're doing. once you explain what you're doing, you have to focus your test. You have to write a test that actually does something. And as I said, the second thing in introducing BDD, Dan talk about different things, about getting rid of the test. Not only does it the test name inside masks the intent of the actual test, it says people don't like it. Developers don't test. Let's call it behavior. We're validating behavior, we're not testing code. We want to validate the code behaves this way. And it's much more useful than tests. And it actually, in one word, changed from doing a tester's job to making sure my code works. Behavior instead of test. Someone else talked about behavior. This is the other DDD, as I said, the other DDD. DDD is domain-driven design. Anyone know domain-driven design? Eric Evans? Yeah, good for you. Very good book. Talks about how to architect big systems. Also comes from Smalltalk. In fact, in the beginning of the book, Eric Evans says, I have a problem. I remember when software development used to be fun, and it was back in the Smalltalk days. And now I'm working in, I don't know, Java. Not so fun anymore. And I'm trying to understand what we did then that we're not doing now. So this one from 2003, from Smalltalk as well, just like Kent Beck ideas. I guess it was a good time for ideas. And the idea is to get one language for the whole team. The whole team speaks the same language. The whole team meaning all the way from marketing down to development, or the other way around, suppose, how do you look at it? Everybody, when we say customer, we mean exactly the same thing. When we say shipment, we talk about the same thing. And it enhances collaboration. And we're talking about experimental and iterative design. And the reason that sounds familiar is because I said the exact same things about TDD and ATDD. So BDD, in a way, is DDD for TDD. It's taking those ideas and putting them in one language for everyone, unit testing world. Usually in BDD, we are talking about stories, scenarios, and steps. Very similar to how we look at unit tests, but there's a twist. We're talking about user story. Usually we'll confirm to this format in order to, as a, I want to. In order to buy a product as a customer, I want to log in to the site. Every story has one or more scenarios, and every scenario are steps. And the steps usually, in most BDD tools, because just like unit testing tools, they copy from one another. You'll have given, when, then. And then off went and created JBehave. And he talks about JBehave in introducing TDD. In the end, he says, I wanted to put my money where my mouth is, so I created JBehave. Later on, he says, that was wrong of me. I didn't create JBehave the right way. So JBehave 2.0, not the one from 2003, the one afterwards, looks like this. This is the second iteration. And the idea is I have at least two documents. One is plain text document for the business guys to read and write. The scenario trader is alerted of status, given stock and threshold 15, when the stock traded down to 5, then alert should be off. That's the business people. Either they write it on their own or they explain it good enough for me to write it. But that's a plain text file. And then I have a code and something to connect them together. And actually, every line in the given when then will execute the method in my code. And I can write whatever I want inside that method. And the business guys can read and write the requirement, and I can read and write the code, and see that both of them works. Now, that's very interesting, because Dan's objective in the beginning, he's talking about that in introducing the BDD, was to fix TDD, not create a completely different way of doing it, but he ended up with this. The most known, one of the known BDD tools is Cucumber. Started from Ruby, actually. And it has a feature. Feature is similar to user story. We take a bunch of scenarios, put them in features, because JBF only have scenarios. Now we have higher level. we have a feature. This is just plain text. The is as doesn't just plain text outputted out. And the scenario over here is the actual code. This is from Cucumber's site, the tutorial they're explaining. In order to avoid silly mistake, as a math idiot, I want to be able to add two numbers. And then I go and actually write a bunch of text that will convert into a code. This is one way of doing BDD. User readable, user writable. And I say user, I mean non-developers. And that's nice. There's another form of BDD that we can see with our spec. Our spec, Ruby, guys, don't really like the fact that we have two files to maintain. Not nice. Make change in one, you need to make change in another. It can be a big hassle. So instead, they're taking the ideas of BDD and put them completely in code. For those of you who don't read Ruby, that's OK. It's very similar. I describe what stack does. It should return blank instance. And new stack should be empty. OK? Same element added to the stack. The new stack, I'll push a value. Then pop should be that value. What's nice about this form of doing it, which looks like a backwards unit test when we look at it, when I run that test, I get the following output. Stack should return a blank instance. Stack element added to the stack on top of the stack. This is user readable. Not writable, but readable. I can go to my product definition guy, show him that list, and says, this is what you meant stack to do? And he'll say yes, or say no, I didn't mean it for that to happen that way. So we'll get the feedback. It doesn't get to write the actual specification in the code. I'm doing it on my own. Added benefit, I just reduce the feedback times. And I can do TDD this way as well. I can do unit tests BDD way with that. I actually call it, and that's my name. They couldn't find a good name. Some people call it lower level BDD. I call it a unit level BDD. The idea is that I'm talking about specification, not scenarios, not stories, not user stories, although I can, in a way. And I replace using unit testing framework with this guy. And it's for developers, for my own. It's for me to then go later on to the business guy and ask him whether or not it intended to happen that way. And I don't need to go to him in person. I can publish it on a site, and he'll verify it on his own free time. And it gives me business readable output. I had a client. They needed to pass an FDA inspection. One of the parts of the FDA inspection is you need to mark a V. Do you have unit tests? I said, yeah, we have. What do your unit tests are testing? Now we have a problem. Well, I can write you the test names, but don't think the FDA will like that. But using this output, I can actually give them something they can work with. Yeah, for you .NET guys, there's a nice framework I tend to use called BDD-Phi. Here you go. This is an actual test in TDD. Is it good enough? Is it readable from back there? Here you go. Just raise your hand in the back if you can read what I'm writing. Yes? OK. So this is the unit test, the TDD test. The problem with this unit test, not that readable. It is for me. I know the business. But for you, you probably need a few minutes or to read whatever I wrote as the test name, which is good. Test name should be very explicit. But I'm doing here something with fake system, and I set it to return 0, the disk space in bytes. And I have some folder. When I ask for the files, it will return 2 files I have over here. And it will call write. It will try to write the log get that is out of this space, and then we'll try to delete those 2 files. This is how it looks with BDD-Phi. It has 2 APIs. This is the Fluent API. I like it better. Given that I'm out of storage space, and there are log files of sizes. And here I give it the sizes of the log file. Each of them is exactly half of the max size. And when write log message, then all log files are deleted. Don't need to know anything about the business. You can read it. It's much more readable. And another fun thing about it, when I run the test, and it will run, and all of them are just methods here that does exactly, I just took that test and extracted to method. That's it. Okay, and the test passed is when I go and to my, I get this file, the HTML BDD file, and when opening it, yeah, low block contact, I can see the test, and I can give it to the guy that actually set the requirement and say, this is what you meant. Was this what you intended the code to do? And he'll say either yes or no. And I can publish it as part of my continuous integration server every time to write all of those. If one of them will fail, see which step failed. It's very nice that way. And I can see that one requirement was not met. And I can do the whole ATDD cycle using those kind of tools as well. And that way I can give the FDA what my code, what I'm testing. Some don't want to change. This is a Catch C++ framework 2 years ago was created. You can either write BDD scenarios with given when then in C++, or write unit tests. Does both, which is nice. You don't have to choose. You can do half and half. And in the result, again, you get the readable output. Well, it is C++. Can be too user-friendly, I guess. And this is what you have. So what we talk about? We talk about TDD Classic and London School of TDD. We talk about ATDD, how it came about, the tools, and specification by example, which is an actual process you can use either with business people or testers. Testers usually are more open to that sort of ideas because it helps their job. And BDD, using either stories or specification, two ways of doing BDD, either the classic way, one file for specification, one file for code, or together with the unit level BDD. So after all this history lesson, what can we take home? What can we do next? Which one to choose, right? This is the whole purpose. I promised that in the abstract, that I'll tell you which one is better. First of all, before that, the most important part is to get your business people, or at least the testers, on board. So the tools does not matter. Whichever tools that work for you, it depends on the company. Some companies are very, I've been to a company and they waste 80% of the time just arguing about requirements. Obviously, ATDD, or high-level BDD, is the tool for them. That will fix their problem. Because that way they'll see the requirements and won't argue all the time. But if I don't get to use the tool of choice, I'll get them to write it somehow. Write it in a Word document. I won't get the automation or verification, and they can write bad things in Word documents, don't need to compile, but at least I'll get them to write it. So the tools does not matter. Use the tools that works for you. Some tools look differently. I really like, at the moment, xUnit for unit testing and BDD5 for BDD when I need, but it changes, and those are .NET tools. In Java, I use something else. Important thing is find the process for your company. And the process should be requirements all the way to code, if you can. If not, at least make sure that your manager understands what you're doing. By the output, by the build server, seeing what passes, what failed, which feature were implemented. Liz here used to, well, not used, still big person in BDD, and she says the tools does not matter. What's important is the conversation. The tools, the BDD tools, the ATDD tools, the whole purpose of them was write in English what you want me to do in code. If you get that conversation in your company, good enough. If not, well, the tools will probably get you there. So which methodology should I choose then? This is a nice comics. Whatever you choose, just don't ask your boss. Because XP, BDD, ATDD, what should we choose? ASAP. In the last years, there's no big difference between ATDD and BDD. If there's something I understood from doing this research, is that people use them interchangeably. Even the articles talking about the difference between ATDD and BDD have a hard time explaining it. And the reason they have a hard time because it doesn't matter, because both of them, I want the user to write a specification, I want to implement the code. Doesn't matter if you do it in Excel or in a text document. Now, BDD and TDD can be used in the same project. I use them in the same project. I use the BDD to write the acceptance tests and TDD to write the unit tests. Because writing ATDD stuff in a unit testing framework is very hard to read. And in fact, I think we have enough time to see this is an old project that I used to work with the guy in our own free time, and unfortunately didn't come about. We're using nbehave. Nbehave is a port of jbehave to .NET. And here we have the file feature, and you can read the feature and understand exactly what happens. We're creating a Visual Studio add-on. And raising Visual Studio the right way with the right files is a lot of lines. A lot, 300 lines of code can be if you do error handling. But instead, just say, well, open a new solution. I don't care how you do it. Open a new solution for me, will you? And then compile it. 2 lines in code. And I want to make sure for the SRN. And in this case, it means that I have actions here that map to those things, just like in JUnit, just in .NET. But another interesting thing is I also use unit tests to test my test runner, the one that runs the test, because I can do that in isolation, semi-isolation. I'm actually reading files in this case, but just a file. And I can do that with unit tests. They are easy enough to write and read. So I can use both in the same project. One for the acceptance test, for the features, and one for the actual unit test, because I need both acceptance tests and unit tests. And this is the major lesson here. And you can also do BDD, ATDD, and TDD with all tools. We developers are very smart. If we have an objective, we'll manage to tackle it. I can write unit tests using fitness. Not a good idea, but possible. And probably you too as well, without realizing, or if you want to write unit tests, although your company asks you to do something completely different. So the tools does not matter. Find the tools that works for you. And then find the methodology that works for the project. Do you want the user in? BDD, ATDD, give them a file to write. They don't want to write a file. Do it with lower level TDD or BDD style unit testing tools, and give them the output, at least to verify that you're doing the right job. The important part is get the conversation flowing. Don't be in your computer all day, then understand that you did the wrong thing. And yeah, Matt is one of the writers of a Cucumber book. And he says that essentially, when you look at what Dan North wrote, BDD is just taking the best practices from TDD and putting them built in so you won't need to teach them and explain to people that they're not doing the job well. You don't need to bring in costly consultants in order to get better tests. Just use the tools. And that's a good idea. Most of the BDD tools will take you there. Because once you start to think about behaviors, it doesn't matter which tools you're using. It will work for you. And I've been doing that without understanding. I used to call it TDD. I'm not sure if I'm going to call it BDD now. But I'm always talking about you have to test the what you want to happen, not how it happened. And this is essentially BDD. So if you take all the ideas of the great TDD minds, they are built in this methodology and this way, with or without your customers. This is from a mailing list, just parting words, from a mailing list about the BDD mailing list, where I'm not sure if it's still active. I wish I knew about it a few years ago, because back then, everybody asked Dan and Liz what they think about BDD and how to do it, and it was an exciting time. And he says, well, TDD is amazing, and BDD is nice as well, and you should have both, and use both whenever, depending on what you're trying to accomplish. Because Lee's talking about BDD is great to get conversation with the users. And I guess that if someone would ask Kent Beck, and you should, he probably says the same thing about TDD, the way he does it, the way he intended people to do it. They just missed the point in the last 10 years or so. Thank you. That was it. If you have any questions, sorry. Here you go. If you have any questions, you can either ask now or afterwards. I'll be around. Any questions? Well, yes.
With the BDD fly, or fine, sorry,
What? Excuse me?
the BDD fine, BDD fine.
Ah, BDD5. Well, .com.
Yeah.
What about it?
Well, that was, that looked like to me that you were writing code before the spec.
Yes, the code is the spec, essentially.
So,
Instead of writing it in a different file, I write it in the same file as the code.
so is that investing development time in actually writing code that you don't know is correct, or is it stubbed out?
Well, the flow goes as follows. I write the spec, it will fail. I'll mark it in some way. It says it failed, but because I haven't implemented it, just in TDD, start writing a bunch of unit tests, get it to pass, and then it passes. I don't think it's wasting developers' time. On the contrary, actually making sure I'm going in the right direction. When I finish writing all my unit tests, this test should pass. Okay, so it's not wasting developers' time. It's actually very fine because unit tests essentially is writing the same thing that people told me. You should do X, I'll write it in code, show it to you, and you say, okay, that's what I meant. So using BDD5, I can show him the steps, say, was that what you meant? If yes, I'll implement it. No, let me think about it again. So it's not wasting time.
So nothing's actually implemented?
No, it will be implemented. No, in the beginning, no, but you only finish once you finish to implement everything. It doesn't stay stubbed out. You have to implement it. I can show you afterwards.
Yeah, please.
Yeah. Okay. Thank you very much.